And from this equation, I was able to get the possible isolations. Okay, this is the main equation. If I isolate for the radius, acceleration and radius exchange positions, so the equation ends like this. And then if I want to isolate the tangential speed, radius goes to the other side to multiply, and because it is raised to the second power, I need to apply the square root in both sides of the equation, or you can use the triangle as a reference for isolations. Doesn't matter. Okay, if you're a simple person and you want to keep these isolations in an index card, that would be perfect. Then we have this exercise that says a test car moves at a constant speed around a circular track. The part that says around a circular track is telling me that we're talking about circular motion because the object is moving around a circle. If the car is 48.2 meters from the track center and has a centripetal acceleration of 805 meters per second squared, what is the car's tangential speed? So I can just write the givens, and also I can do the sketch. I have the car, I have the center of the path, and I know that it's moving around a circle, so I put these arrows to indicate circular motion, indicate the data, and then I just look for what the problem is asking me. It says, what is the car's tangential speed? They are giving me acceleration, and they're giving me distance from the track center, which is the radius, in other words. So they're giving me these values, okay? And all I do is I apply the formula that corresponds to the question. It says tangential speed, so I will use the formula for tangential speed, which is this one. This is the procedure, the isolating procedure, okay? Radius was dividing, goes to the other side to multiply, okay? And once they are multiplying, to get rid of the square, I apply square root both sides of the equation. That's why the equation isolated is like this. Plug in the givens, chalala chalala. This is how you obtain the units, meters per second, and very simple. Okay, very simple. Today I will solve one more example about centripetal acceleration, and we're going to go into the next equation, that is okay, centripetal acceleration and centripetal force. Okay, give me just a second. Okay, in this exercise it says the cylindrical tube of a washing machine has a radius of 34 centimeters. During the spin cycle, the wall of the tube rotates with a tangential speed of 5.5 meters per second. Calculate the centripetal acceleration of the cloth sitting against the tube. Okay, so we are talking about a washing machine. If you ever have washed your clothes, you have noticed that internally, I mean, any washing machine works with centripetal acceleration. Okay, so more or less, this is your washing machine. Now, it said that this cylindrical tube has a radius of 34 centimeters. So from the center, okay, from the center to the edge, I have 34 centimeters. Okay, it says that during the spin cycle, the wall, the wall is located here in the edge. Okay, this is the wall. So this wall rotates with a tangential speed of 5.5 meters per second. So this one has a tangential speed 5.5 meters over second. This is how the rotation occurs. So more or less, that's how it works, okay? So the rotation occurs at a tangential speed of 5.5 meters per second, and they're asking me to find centripetal acceleration. So I'm going to write my data right here.
Miss,
Yes, tell me.
in case of if the problem maybe says that it's accelerating uniformly, like if it has change of velocity, what we will do?
In this case, it's not mentioned, okay? It is not mentioned that it is uniformly, but as I told you, um, these are like conceptual exercises, so they are based on assumptions like the one you said, that is moving at a constant. That is just a condition. In the end, as I told you, in the end, in the real life, there's no way that a constant of something really occurs. So in this case, the centripetal acceleration, even though in real life won't be happening, but in the end, in for this kind of exercises, you will assume that it does.
Thank you.
Okay. Okay, so given the radius that is 34 centimeters, you know centimeters doesn't work for us, so we need to convert from
Yes.
centimeters to meters. Okay, so the conversion you already know. In 1 meter, you have 100 centimeters.
0.34 meters.
0.34 meters. Okay, and the tangential speed, which is Vt, is 5.5 meters over second, and they're asking you to find AC. Okay, AC is unknown, and according to the formulas that I gave you, chalala, chalala, here are the formulas. AC, which is centripetal acceleration, is equal to Vt squared divided by radius. So this is the formula that I will be using. Since I'm lazy, I'm just going to copy and paste. So solution, this is the main formula. Okay. Okay, this is the main formula, and all you do is substitution. AC is equal to Vt is 5.5 meters over second to the second power divided by the radius already converted to meter, that is 0.34 meters. How much did you get?
The final answer.
Yes.
The final answer is 88.97 meters per second squared.
Okay, 88.97 meters over second square. Now, how do I always teach you how to get the units. In the end, you basically don't use it because you just I kind of repeat what I do, but I always try to teach you how to do this. Um, you have meters per second that are raised to just the units, okay? Meters per second to the second power is equal to meter squared over second squared. Since you are dividing by meters, this square from here is going to be cancelled with the meters below. Because just remember, meter squared is the same as having meters times meters over second squared divided by meters. So you cancel just one of the meters. And the final answer will be meters in the top, second square below. So the final units will be meter per second square, which are units that we know for acceleration. And it makes sense since we are looking for centripetal acceleration. That's how you get it. That's always like an extra step that I show you, that it is important, but not all the time you do it, okay? But it's good that you know this. It's very good that you know this, where the units are coming from. And this is why, take a look here, when you cancel the units, this is why we need to do the conversion from the beginning. If you do not convert centimeters to meters, you wouldn't be able to perform this cancellation of units, okay? So please, every time you see units that are different than meters, it doesn't mean that you cannot work like that, but you need to be consistent. I mean, if I'm giving you the radius in centimeters and the velocity in meters, so units don't match. Always try to make the units match. And voila, that will be it. You can see the procedure actually is very simple. And since I already gave you the isolations, all you have to do is plug in the givens. That will be it for centripetal acceleration. Now, one other formula that we are going to be seeing in this circular motion is centripetal force. Let's go back to the second partial when we learned about Newton's laws. In the second Newton, in the second law, it says that force is equal to mass times acceleration. This is important because this centripetal force is a force, which means that it's going to be measured in Newton, etc., etc. But the idea of the force is coming from Newton's second law of motion. Now take a look to this. Because you know that force is equal to mass times acceleration, then centripetal force is going to be equal to the mass of the object, but this time we're not going to use normal acceleration, we're going to use centripetal acceleration. So this is the equation that we are going to use to find centripetal force. And you might be thinking, Miss, but that formula is different than the one that you are giving us. They are not the same formula. Okay? Yeah, it doesn't look the same. But remember, I already gave you the formula for centripetal acceleration. I will use it in the exercise above, okay? Centripetal acceleration. We have a definition for it. So I can make an arrangement of this formula. I can adapt it. And I can say, okay, centripetal force is equal then to the mass times centripetal acceleration, which according to the formula, this is tangential speed to the second power divided by the radius of the circular path. And now take a look. The two equations are the exact same. And they were the same before. Okay? So, this, even if you don't know the formula for centripetal force, what I'm showing you is how to get it. Okay? This is the main formula to get a centripetal force. And all you do after are the isolations. So in case that you want to know the radius, okay, in case you want to know the radius, radius and force just exchange positions. So this is going to be mass times tangential speed to the second power divided by centripetal force. Okay, if you want to know the mass, you isolate it. This one is dividing, goes to multiply, and this one is multiplying, comes to divide. So the isolation is going to be r, the radius, times the centripetal force divided by vt squared. If you want to know vt squared, well, you don't want to know what vt squared is. You want to know what vt is. Okay, but this one we can do it step by step. So take a look. This is the main equation. Focus here. I'm going to do the isolation from this part, and then here I'm going to write just a final isolation. So you have Fc equals mass Vt squared divided by R. I'm going to start isolating radius. It is dividing, goes to the other side to multiply. So this will be Fc times R equals m times Vt squared. I want to isolate Vt squared. So this m is multiplying, it's going to come to the other side to divide. So Fc times R divided by m equals Vt squared. Okay? And since I have a square right here and I want it to be linear, what I do is I get a square root, but not just in one side, but in the two sides. So these two are going to be canceled. And here is the equation for Vt. Okay? So Vt, tangential speed, is equal to the square root of centripetal force times the radius of the circular path divided by the mass. So those are the possible isolations that you are going to need. Question: do you want me to leave this procedure here? Do you want me to leave it here in the PDF file, or I erase it?
Yes.
Yes.
Okay. Okay. Bueno, I'm gonna leave it there. I don't like it, that's why I always erase it. But I'm gonna leave it. So those are the possible isolations, and of course the main equation. The main equation, I'm gonna put it also here because it's the main equation. It's gonna be like that. So Fc is equal to m Vt raised to the second power divided by R. So those are the formulas that you can use for centripetal force. Now, how you identify that you have to use centripetal force depends on the word problem. Let's take a look to this word problem from here. A pilot is flying a small plane at 56.6 meters per second in a circular path. Okay. Important information, circular path. It's telling me that it's circular motion. Okay. That circular path has a radius of 188.5 meters. Now, it says that centripetal force. So this is mentioning centripetal force, so that you know then that you have to use any of these questions, any of these isolations, sorry, okay? Because the centripetal force is mentioned in the problem. Centripetal force needed to maintain the plane's circular motion is 189 times 10 to the fourth power Newton. What is the plane's mass? So, I'm going to start by writing the givens. Okay, the circular path with a radius of 188.5 meters is going to be my first given. Okay, so the radius is 188.5 meters. The centripetal force needed to maintain the plane's circular motion is 189 times 10 to the fourth power Newton. So Fc 1.89 times 10 to the fourth power Newton, and it's asking you what is the plane's mass. So I'm looking for the mass, which is going to be my unknown. Okay? Miss, but if I'm looking for the mass, I have to use this equation. Okay, yes, that equation. You have to use it. But if you notice, they're just giving us radius and force. They are not giving us Vt squared or Vt in general. Okay? So that means I don't know Vt, so I cannot know the mass yet. But you do know the formula to get the tangential speed. So we go above to look for the equation for Vt. Vt, or tangential speed, is equal to the square root of centripetal acceleration, that is multiplying the radius. Okay? You can use this one. I'm sorry, yes, they are giving us the formula. A pilot is flying a small plane at 56.6 meters per second. Sorry, this is the VT. Estaba más fácil de lo que pensaba. Okay, VT. So give me just a moment. I'm blind. Old and blind. What can I ask for life? Well, then I have everything I need. It's even easier than expected because I have everything I need. Okay, I have the radius of the circular path, the force, and I have the speed. All I need to do is plug in the givens. Now, the solution of this problem is very easy. Just apply the formula. Just apply the formula. I'm gonna show you the solution, the isolation process. Okay. So this is your main equation. M times Vt to the second power divided by the R. Okay. So the first thing I move is the radius. It divides, so I send it to the other side to multiply. So Fc times R equals M times Vt to the second power. Okay, now Vt to the second power is multiplying the mass, so I'm gonna send it to the other side to divide. So Fc times R divided by Vt to the second power will be equal to the mass. This is the procedure that I do for isolating mass. Okay, so I apply the formula I'm just going to arrange it like this because I like it more. And I will just plug in the givens. Fc, which is 1.89 times 10 to the fourth power Newton times the radius 188.5 meters divided by Vt to the second power, which is 56.6 meters over second to the second power. How much is this?
The final.
Yes.
Gonna be
1,112.1.
1,9.
0.09 or 0.1, both are
Oh,
correct,
yeah.
don't worry. I just prefer the 2 digits after the decimal point, but that is my personal choice, okay? Because we're talking about mass, and all the units are, well, corresponding units. This answer is going to be in kilograms. Like that. Okay, just remember that a Newton is kilogram meters over second square, okay? So you are multiplying kilograms meters over second squared times meters, and you are dividing by meters per second to the second power. Sorry, you're not seeing this. Okay, this is how you obtain the units. Okay, these meters per second that are raised to the second power are going to end up like this: meter square over second square. Okay, so these meters with meters are gonna cancel these meters from the bottom, and this second square gonna cancel with this second square. So that remaining unit is going to be kilograms. That's how you obtain the kilograms. Now, you don't need to do this procedure really because all the units are corresponding. I mean, your force is already in Newton, which is expected to be. Your radius is in meters, and your speed is in meters over seconds. So all units are corresponding. That's why when you cancel the units, there's no way that you obtain something different than kilograms. Now, if for example I give you the force in pounds, then you wouldn't get kilograms. You will have to perform a conversion before starting the problem. But that's a different situation. I'm just telling you how to deal with it. That's gonna be the final answer. I don't know if you have a doubt about this exercise. Okay, well, let's try with this one. It says the royal antelope of Western Africa has an average mass of only 3.2 kilograms. Suppose this antelope runs in a circle. Runs in a circle is telling me that this is circular motion. Now this circle has a radius of 30 meters. if a force of 8.8 Newton maintains this circular motion, what is the antilope's tangential speed? I'm looking for the tangential speed of this antilope. Okay, so first I write the givens. So I know the average mass, or I'm just gonna write the mass, that is 3.2 kilograms. That's a very light antelope. 3.2 kilograms are about like, let me see how many pounds. 3.2, 3.2, around 7 pounds. 7 pounds. 7 pounds. My cat weighs more than this antelope. I mean, the fat one. The fat one, my fat cat, she is 14 pounds. It's double. Okay, it's only for you to know. Okay, well, that antelope runs in a circle. The radius is 30 meters, and it has a force, centripetal force, of 8.8 newtons. And I'm looking for what is the antelope's tangential speed. So I'm looking for Vt, which is my unknown. Okay, so according to the formula, I already have an isolation for Vt. That is this one. Okay, so right now I'm just going to copy and paste. Well, I'm going to copy and paste that too. Is that I like to show you the procedure, the isolation procedure. I don't know why I like to show you that. Okay, solution process. Okay, you have your main equation. No voy a tener tiempo de mostrarles el procedimiento. The isolation procedure, just this one. Ni modo. Hoy no. Okay, this is the equation for tangential speed. And just check that you have everything. Mass and mass, radius and radius, force and force. So you have everything you need to get it. Okay, so all you need to do is plug in the givens. So tangential speed is equal to the square root of 8.8 Newton times 30 meters divided by 3.2 kilograms. Remember, solve everything that is inside first, and then apply square root of your answer.
9.08 meters per second.
9.08 meters per second, that is correct. And voila, you can see the formula for all this is very simple. So I'm going to assign you a homework for the two topics, so you can practice the two topics.